This is 5.3 part 3. We're going to be looking at writing formulas for polynomial functions. So how to write the formula for a polynomial function given the graph. First, you want to plug in the x-intercepts into factored form of the polynomial. X minus x1, x minus x2, where x1 and x2, etc. are the x-intercepts. So let's say I see that I have an x-intercept at 0, I would want to do x minus 0, which is just x. If I see I have an x-intercept at negative 2, that would be x minus negative 2, which would give me a factor of x plus 2. So you're just going to plug those into factored form. And then you want to determine the multiplicity of each factor based on the behavior of the graph, like we talked about in part 1. Based on the behavior of the graph at the x-intercept. So whether it bounces, goes straight through, or curves through, that'll tell you kind of what your exponent here should be. So let's say it bounces off at 0, then I would want to put at least a 2 there, 2, 4, 6, something even. Let's say it goes through, but it has a bend at negative 2, so that would tell me that it should be something like 3. Okay, so that's kind of how you're going to do that. That will be finding the polynomial of least degree containing all the factors. So when it says of least degree, it just is saying if it bends and it goes through, then just put 3. Don't put 7 or just something obnoxiously large. Put the lowest number that it could be. So if it goes straight through, 1. It bounces, 2. It curves as it goes through, 3. Use any other point on the graph. The y-intercept is a good option to determine the stretch factor. So your polynomial is going to be like this. F of x equals x minus something, whatever your x-intercepts are, to some power. I'll say n, x minus your other x-intercept to some power. Okay, but that's not necessarily the whole picture, right? It could have a stretch factor, and so what that's going to be is a coefficient here. So we can call that a, but what you're going to do after you have the polynomial in factored form is plug in one of the points that's on your graph and solve for a. Figure out what a should be. So if you use the y-intercept, then you're plugging in 0 for x and figuring out, and the y value, of course, for f of x, the y-intercept for f of x, and then you can solve for a. All right, so let's see how that goes on number 5. Write a formula for the polynomial function shown in this graph, okay? So I've got 3 x-intercepts. That's the first thing we need to notice. I've got 3 x-intercepts. I have x equals negative 3. And that one looks like it has multiplicity 1, just goes straight through. I have x equals 2, and that's multiplicity 2, since it bounces. And I have x equals 5, and that one also goes straight through, so multiplicity 1. So now we're going to plug those into factored form. That would be x minus negative 3. Okay, the reason that you put x minus negative 3 instead of just x minus 3 is because remember the way that you get your zeros is by setting the factors equal to 0 and solving for x. So if I subtract the 3 over, I get negative 3. So that's how you get that. So you're always going to be changing the sign when you put it in factored form. All right, so that's going to be x plus 3 to the power of 1. We have that coefficient there that we don't know what it is. We don't know what that is yet. Okay, and then we have x minus 2 squared, since the multiplicity is 2. We have x minus 5 to the power of 1. All right, so that's my polynomial, except I don't know what the stretch factor is right here yet. So let's figure that out. To do that, I could use my y-intercept since it goes straight through -2. So that's 0, -2 is a point on my graph. So I can plug that in to the polynomial and solve for a. So -2 equals a times 0 plus 3 times 0 minus 2 squared times 0 minus 5. So that's 3, -2 squared, -5. You can multiply all of that together in your calculator, but you really don't need to. Let's see, 3 times 4 times -5, -60, and then I would divide by -60, so that's 1 over 30. All right, now that we know what a is, we can write the polynomial function. We're going to leave it in factored form just because I'm nice. We could multiply everything together to get it in standard form, but that would be a lot of work, so we're just going to leave it like this. So you could distribute that 1/3, FOIL everything together one at a time like we've talked about in the past to get it in standard form, but we'll just leave it in factored form. And that would be the formula for the polynomial function. All right, number 6. My x-intercepts. I've got x equals -1, and that one has a multiplicity of 2 since it bounces. I've got x equals 2. That one has a multiplicity of 3. Since it goes through but it curves, and honestly it might be multiplicity 5. You can't really tell just by looking at this graph, but it does get pretty flat there. So because it goes through, you know it has to be odd, and because it bends, we know that it's not 1. So we're going to go with the lowest possible thing that it could be, which is 3. And then at 4, goes straight through, so that's just a multiplicity 1. All right, so let's write that polynomial. We don't know the stretch factor, but we do know x plus 1 squared, x minus 3 cubed, and x minus 4 to the power of 1. All right, now we want to figure out the stretch factor. So it looks like it goes through at -4, but let's see if there's any other points we can use. No, that's really the only thing that we have, so we'll assume that that was going through right at -4. Y-intercept of -4. All right, so we'll plug in 0 for x and -4 for y. Solve for a. Okay, I believe I'll just type that into my calculator. -3 cubed times -4 gives me 108. Divide by 108. That reduces to -1 over 27, which I just did in my calculator. I did -4 divided by 108. That gave me a decimal. I hit math frac, so it would give me that reduced fraction. All right, so we will plug that a back in and we will have our polynomial function written in factored form. -1/27 x plus 1 squared x minus 3 cubed x minus 4 to the power of 1. And that's how you write the polynomial given the graph. So you're going to use those x-intercepts, and then you're going to solve for the and use the x-intercepts along with the multiplicities, and then also solve for that stretch factor by plugging a point in. All right, last part of these notes, we're talking about local and global extrema. So we have what's called a local max or local min, local maximum or minimum. It's the y value at the highest or lowest point on the graph on a given open interval. So open interval meaning you're not including the endpoints of the interval. And so on some interval, you're saying this would be the highest point, the local maximum would be the highest point on that specific interval. The local minimum would be the lowest point on that specific interval. So if you look at the graph here, this is considered a local maximum because on this interval, right, it is the highest point. If you just look at that interval, it's the highest point. So really it's any turning point that is a maximum. That would be a local maximum. And then any turning point that produces a minimum is a local minimum. Okay, because on some interval, that is the lowest point. And then we have a global maximum or a global minimum, which is the y value at the highest or lowest point of the whole function. So you're looking at the graph, the entire graph, not just a specific interval, and you're saying what is the absolute highest point of the whole thing? That would be a global maximum. So that's why here this is the global maximum, because that's the highest point of the entire function. 5 is the global maximum. Now you can't get a global minimum from this because we keep going down, down, down forever, okay? So this is not the global minimum because there are other points on that graph that are below that point. Those arrows make it to where you cannot find a global minimum because it's going to negative infinity. All right, so on this example, we're going to use technology to find the maximum and minimum values on the interval -1 to 4, on the interval -1 to 4 of this function. All right, so I plugged that function into y equals, and now let's take a look at the graph. So here's the graph. I could I'm going to change my window. I'll show you how to do that so that I only see the interval -1 to 4. So to do that, hit window. They're talking about the x values, so I want my minimum to be -1. I want my x maximum to be 4, and that will give us a better look at this graph. All right, so looking at this graph, let's get actually, just looking at it, let's see what we can find. So right here, close to x equals 0, I see a minimum definitely there. Now, because that is the lowest point on the entire interval that we are looking at of this polynomial, that's going to be a global minimum at that point. Now I see a maximum occurring over here to the far right. That is going to be considered a global maximum because it's the highest point on the entire graph that you see, on the entire interval. Now there's another turning point that you can almost see over here at x equals -1. So that looks like it would have been a local maximum. The issue is that we're looking that there's no open interval around -1 for that maximum. So if you read the definition, it says a local maximum is the y value at the highest or lowest point on the graph on a given open interval. And so because the interval that we're looking at cuts off at -1, I can't put an open interval around -1 to call that a maximum. So basically, if you can't put an interval, like an open interval of x values around that, like I couldn't say that's the highest point from -2 to -0.5, right? That would be a local maximum. But I can't go to -2 because my graph stops at -1. Okay, and so that one doesn't count. So we really, for this one, we just have global maximum and minimum. Let's see how we can find those using technology. So we'll hit second trace. To get the minimum, we'll go to 3. So we're at the minimum here. Hit enter to the left of that minimum. Move to the right of the minimum. Hit enter again. One more time. Now it says minimum. So you have a global minimum at the point 0.093 -6.474. Okay, and then we have a global maximum. Let's find that one. So let's get that point. So we'll hit second trace 4 this time to get maximum. We're gonna have to scoot all the way over until you get to that maximum. So it's gonna take a second. So first you're gonna hit enter just to the left, just to the left of that maximum. Move to the right of the maximum, hit enter one more time. Enter a third time, so it says maximum is at 3.573 approximately, and the y value is 6.951. All right, so that's how you can get those maximums and minimums using your calculator. That is it for the 5.3 notes. All right, have a good day.